All right, so here we're going to move on to kind of talking about uh, still in the ratio area, but a different concept or a different idea than what we've already talked about with scale here. But there's also some similarities to it. So on the screen, you can see that I took a picture of a page in a catalog that came in the mail the other day. And there's a bunch of different kinds of Halloween candy that I could buy. Now, we know in the real world, sometimes when you buy candy, it's because you want to buy your favorite. So for me, I think I would definitely buy this one here that has Milky Ways and Twix because that's delicious. Sometimes when we buy things in the real world, we buy them based on how much they have. So you might look at these ones over here and see there's only 60 pieces and decide that's not enough candy for you. Or on the flip side, you might look at this one that has 288 pieces and decide that that is way too much. You don't want to eat all that or have that in your house. You won't have that many trick-or-treaters, so you don't want to get that one. But what if the only thing you wanted to look at was which of these was the cheapest? So how could you get the cheapest candy to hand out for Halloween? Well, that's where what we're going to talk about in our next lesson is going to come in handy. That's one of the real world applications to it. So you can see on this page, they helped us out on two of them. They said this one costs 18 cents for each of them. This one costs 16 cents for each of them. But how did they get those numbers? And how could we get those numbers for all the other kinds of candy on here? You could see it's kind of easy to compare, say, this one and this one because they both cost 17.99. And so then you could say, oh, well, they both have 100 pieces, so those two are pretty comparable to each other. But all the other candies cost different amounts of money and they have different amounts of pieces. There's 288, there's 260, there's 230. So how do we know for sure, especially if it comes really close, like 16 cents and 18 cents are not that far from each other? The key to answering this question and other ones similar to this here is something called unit rate. So go ahead and go to this page in your math notebook if you haven't already. You can pause it. Okay. So here we go. The first part, we're going to type in the definition, and then you're going to put it in your own words. So a unit rate is going to be a rate where one of the quantities, or numbers is another word for that, is 1. So that's going to be kind of your secret here. So already, hopefully, in your mind, you're kind of connecting that this is similar to scale, and that really, when we were finding the scale factor, we were finding the unit rate for the problem because we had to find that special number 1 there. And so we do the one number 1 in unit rate for the same reasons we did it with scale factor. Because it's easier to do the math, we can just multiply and divide by the other number that we see so that we can solve the problems and have that comparison. So right now, it said to put in your own words, so you could go ahead and hit enter and then go down and put this in your own words. So you can pause again here. Okay, so if I go to the next part, characteristics, qualities of the word. So it is a rate. We do have to have one number is 1. They could both be, but you definitely have to have one of them. And the other thing that I want to put here that's really important with unit rate is that oops, spelled that one wrong. Labels matter. So I have to be really careful when I do unit rates that I know what we're talking about here. Because if I go back to this problem here, we could figure out that it costs 18 cents per piece of candy, but we could also figure out how many candies you get for $1. So we could have done it in a different way. So which one do you get the most candies for $1, or which one's the cheapest? Which one is the lowest price for one piece of candy? You could see how both those situations have a 1 in them, but one time it's 1 candy and the other time it's $1. So labels are going to be super important. Okay. So examples of a unit rate, you hear like we saw on the other page there, it is 18 cents per candy. Or you might see that the speed limit is 55 miles per hour. So that's going to be your idea of unit rate. Even though there's not a 1 here, we know that really it means 18 cents per one candy or 55 miles per 1 hour. Okay. Non-examples of this word would be anything that's a rate that doesn't have a 1 in it. So let's say that you can run 2 miles in 15 minutes. Okay. It's still a rate because it's kind of how you can do this here. It's comparing those two quantities, but it's not a unit rate because it doesn't have a 1 in it. So go ahead and make sure you have all this information in your notes and then use your notes to help you answer the questions at the end of this video.